Good afternoon, everyone. So we'll talk about using MATLAB effectively on GRAM and Cedar. My name is Jamie Hu. I'm a HPC consultant at Sharcnet and Computer Canada, and based at University of Waterloo. So, as we have posted online for the abstract of this webinar, we are not talking about how to write a good MATLAB code, nor talk about how to use the toolbox for specific research. We're talking about how does MATLAB perform on Computer Canada systems, on GRAM and Cedar systems. And the purpose for us is to make use of our systems effectively. So there are 4 ways for you to use MATLAB on Computer Canada systems. So that's the topics we listed here. So you can run interactive MATLAB jobs. You can run the batch jobs in slurm. So you submit jobs to the queue. That's the standard way to run a job on the cluster. And then we'll talk about how to use a parallel computing toolbox, so to do the parallel computing on the cluster. And lastly, we'll talk about MATLAB compiler runtime. So that's for someone, if in any case the license doesn't work for you on GRAM, for example, and if you want to still run MATLAB side, that's the other way for you to run MATLABs. Okay. So the first thing I think all of you already know, MATLAB is a licensed package. So it comes to a licensed package, or you need to understand how does the license work and where it is. So luckily for all of you, we have a license on Cedar that's available for all Computer Canada account holders. So you don't need to worry about a license to run MATLAB on Cedar. However, on GRAM, it's either use your institution license or your group license, whatever the connection can be made. So right now, we have about 10 institutions who already set up that path for you to run MATLAB on GRAM. So if you happen to be within one of the institutions we listed here, and basically you are registered with your local MATLAB license. So I know how does it work at University of Waterloo, because I'm physically sitting here. So basically, you are registered with that license pool, and your Computer Canada username matches your institution username or institution ID. Because you're registered with your local license, let's have your local institution ID in that license file. So you don't need to do any extra whatever settings, and you simply start it and it will work for you. So for those, if you are your institution is not listed here, well, it doesn't mean you cannot run. And however, you may have to do some extra work. So we hope you can contact your local campus MATLAB license maintainer and Computer Canada staff if you have one locally. As long as the campus MATLAB license maintainer allow the license server be accessed from GRAM, and would like you make it at that tunnel and to use the institutional license. Unfortunately, some campus they are not so friendly to support this type of applications. So it's up to them. It's up to your local MATLAB license maintainer to make it work or not. So if you don't have this type of settings essentially, and maybe if you have a local MATLAB license, MATLAB.exe file, you can put that file under your data licenses directory under your home, and we'll see whether it works or not. Or basically, they need to build a communication with the license server. And for us, we need to know where is the license server domain name and the port to access to it. Anyway, you can contact us, and you can send an email to support at computercat.ca. We'll try to help you. So if you want to know what type of MATLAB versions are available on the cluster, all the packages are installed on the module. You simply type module slider MATLAB on GRAM and on Cedar. They are exactly the same. So you can find so far we have 4 different versions on the systems. So there's a 2014A, 2016B, 2017A, 2018A. So we'll try to install more if you need it, and also try to catch up with the latest MATLAB versions. I think 2018B is available now, but our systems our staffs will have that installed at some point, as long as they're available for that. So we always suggest you where we think the latest version will have more features, particularly some new features or some older features. They can run more efficiently. So try to use the latest version on the systems as possible. So if you use it, so your module load MATLAB as the version of the package, and pretty much I think you're on it. So originally, I planned to run this webinar by live demo. However, I found sometimes it's hard. It takes time to actually do it on the systems. So instead, I made lots of snapshots, and I basically posted all on my slides. So at the end, I think the slides, if you simply look at my slides, and I hope that will be helpful. It's consistent. It has all the information you may need for you to run MATLAB on computer contact systems. So the first thing is to run interactive MATLAB jobs and use slr to reserve a computer resource. So this is the way and to do the single CPU MATLAB jobs. And then if you happen to need to run PCT, such as, so for example, use 4 workers, so you use that CPUs per task equal 4. Okay, and in case you deny to open a GUI, the first thing is you need to enable X11 whatever tool on your desktop. If you are on Linux or on Mac, it's already there. It's not a problem. So what you need to do is to add --X11, and then you could be able to reserve a computer resource, and then you can run MATLAB GUIs. And sometimes X11 forwarding is slow. And if that's the case for you, would suggest you to use VNC instead of X11 forwarding. And you can find this wiki page. I think it's here to how to set up VNC on your client machines. If you have any issues, and you can email support that computer.ca, and we don't have time in this seminar to talk about it. Sometimes, well, it's time consuming. Okay, so here is a snapshot for the slog long GUI interactive sessions. So the command used is slot. So I ask for 1 hour, 1 CPU, for my default account. I ask for 5 GB memory for this interactive job. So when you type in this command, and the system will try to allocate, and this is a job number for you, and it's waiting for the resources. Sometimes it will go very quick, sometimes it may take a few minutes. And once it's done, it will say, well, your interactive allocation is available now, and you'll go to a load. So it's a computer node here will allow you to run your jobs. So your type of command is from login node, and then the result will be 1 computer node is available for you to run interactive jobs. So once you are on this load, and then your module load MATLAB say 2018A, and then you can go to your file directory. So in my case, I have this MATLAB subdirectory under my home, and I try to write a series of jobs here. You can find your file, you can check your file, and for the long GUI application, when you start MATLAB, you will need to add -no display these options, and then you can find MATLAB window will open for you. And then this is basically the same thing as MATLAB GUI. So I already have that .m file. If I run this one, you can see your MATLAB will start to run. So this basically is the same for you to start interactive MATLAB job. Don't run the interactive jobs on a login node. And this is the right way to run interactive jobs on Gram and on Cedar. The next page will say, well, the GUI is actually works. So if you simply add --x11, assuming you have that x11 and opened on your local desktop, and the same thing, it will work for you. In this case, you do the module load MATLAB 2018A, and you basically type MATLAB, and you wait there to say MATLAB is selecting OpenGL rendering. And it may take a minute or two. You can find the GUI, MATLAB GUI will open for you. And you can find whatever folders there, and you can do the interactive GUI applications. So for example, in my case, I find my directory, and I find my code, and run your code. And when you run your code, GUI will work for you. Again, if this x11 forwarding doesn't work for you, or somehow if it's slow, try to use a VNC connection. That will certainly work. Okay, so this is the way and for interactive jobs. However, as we said, our cluster is a big cluster and it's shared by many users. So we don't hope all of you to basically build that interactive running. And we hope you have your code, and you have code ready, and you submit a job to the queue, particularly for some jobs that run for a long time. If you want to terminate it, you basically type exit, and it exit to come back to your login node. So basically, you want to submit a job to the queue. So here is the same code. So all my slides were usually the same code. So this is ideal code, ideal simple code you calculate pi, use numerical integrations. And it's nothing fancy. It's basically, it depends how long you need it to run. If you cut it to small chunks, you increase this number. The whole code is basically one loop. It's a for loop, and you will do it, right? Assume you have a .m file, and then you want to submit this job to the queue. So this is a typical sample batch script for you to submit. So in your script, as you know, you need to use what type of group account you have, and then how many CPUs to use. For sequential jobs, it will always be 1. And then is how much memory your job will need. And then is how long your job need to run. And then is the output. Some users, you will like to have a set of email notification or the job name or whatever. It's purely up to you. And then on this script, which MATLAB version do you use? You do the modulo. And then you use the command will be slurm MATLAB because it's no display. And because it's a single job, so you would like to add batch single com thread. So that's basically, you don't want MATLAB to auto-threading a lot. And then this is the code, is the .m files -r for you to run. Once you have this script, make it be executable, and then you submit the job to the queue. Use sbatch, and then is this .sh file. And actually, if someone always want to import output, is actually you can use sbatch -import instead of -r for your code. It all works. And I think MATLAB prefer for you to use -r in slurm, that command. Okay. So once you submit a job, and then because I set up where the output file is .log, and then if you go to open this file, and this file will have MATLAB, and you can find, or this is output, and the code basically run. So this is the way I think it's for most of the MATLAB users, and to run standard sequential jobs on a cluster. And then the following, I will talk about spend a little bit more time for people that use parallel solutions. We talk about parallel solutions. MATLAB actually has 2 solutions to it. One is the parallel computing toolbox. So this is a shared memory solution. So it's basically, because it's shared memory, all the CPUs should stay the same memory. So that means your code can only use as many CPUs on one node. It's not a cross node. So in parallel computing toolbox, I think basically they may have others, and it basically has 2 features. One is the parallel loop. We use PAR4, and the other is called SPMD. SPMD basically to open a bunch of workers, or like you call it labs, to solve tasks. I think it basically take the same programming mechanism as OpenMP. So SPMD is more like a parallel region. It's open parallel region for you to do what type of computations you need to do. And PAR4 is quite straightforward. The other one is a MATLAB distributed computing server, called MDCS. We don't have it. It's separately licensed, so we'll not talk about it at all. But basically, it's the way to run MATLAB jobs cross nodes. something like MPI, that type of approach. So MathWork actually runs series of webinars to talk about, teach you how to use the parallel computing toolbox and how to write a better or good MATLAB code, and how to use the parallel computing toolbox for specific applications. So yeah, if you really want to learn how to write the good MATLAB code, you're welcome to MathWorks seminars. And we are not on that position to talk about the details. However, and because we support MATLAB on our systems, we will observe how does it perform on our systems. We hope to pass the observations or experience to you, and hopefully that will make sense, and that will somehow let you know, you can use it better on our systems. It doesn't matter how good a package, right? Because it needs to run on specific systems. So you need to understand a little bit the knowledge, the hardware of the systems, to make the best of the package. The parallel computing toolbox, the first thing you will think about is actually how many workers to use. So because actually it's automatic pool enabled, so MATLAB is reaches the first path 4 or SPMD data 9. It will try to start a parallel pool and then run your parallel path 4 or run your whatever command on the SPMD in parallel. And the number of workers, it barely depends on machine or on a load on our clusters. So if your machine has, say, less than 12 cores, 12 CPUs, so the default pool opened will match whatever the physical CPUs on your machine. So in the case on our machine or node is more than 12 cores, the default in MATLAB is 12. So if you just run your code, it doesn't matter how many CPUs you set up for it. It will always open 12 workers. So MATLAB provides that tool called a path pool to override that numbers. So you need to add a path pool. Say if you want to run, say, 20 workers, and then you need to override that 12 workers. Okay, and then we can show you a few cases. So as long as you use under 12 workers on our systems, you don't need to use a path pool. And the same code, and the code, the only difference is change the for loop to be path 4. That's the only difference. And then you have this code, and this script is to run to use 4 workers. So what's the difference is here? You need to use a dash CPUs per task, because PCT is a threaded solution. So for threaded job, it's one process, it's one task. However, it's one task will use multiple threads. On our system, we'll try to run one thread on one CPU to make the best performance. We don't want multiple threads on one CPU. Have this set, and you set up memory. But when you run PCT, because you use more cores, you have the chance to use more memories. And again, you set up for the path 4. And because you run PCB, and then you don't use that single COM thread. If you use single COM threads, it will not span threads. it doesn't run. And then you basically is run MATLAB additional. I think it is the well, basically it's additional display or kind of all, and you run it. And you submit this script, this job, and you wait for a while. You can see the output something like this. And yeah, and you can see how many workers you actually use starting parallel pools and use local profile. You can see how many it connect to. It actually uses 4. And whatever the output your code will does. Okay? So the same code, and if you say I want to use 12. So the scripts, slurm script basically only give you physical hardware. So we give you 12 cores at this time. In this case, you will run the same code. Nothing else changed. You can see the output. So the output basically, or you this time say told you MATLAB actually open 12 workers do the job. And I think I ran this, or this is on RAM. You can see the timing is actually makes sense too. And, because you use more workers, and you hope your job will run faster. And it is the case here. If you say needed to use more than 12, so in this case, say I use 20 CPUs, 20 cores, right? And then your code, if you simply run the same code, because the same code will by default always open 12 workers. You don't want that's the case. So then you use a part pool here to override that 12. And this is a simple solution. Maybe you can part pool has all options. The simple one is basically give the number of workers here. So if you here set up, it will all the code has nothing to change. And you submit that job, and you can run it. And if you run it, you can see at this time it's actually open connected 20 workers, right? And then whatever results here. So on a cluster, so what's the maximum? Well, that's a little bit about the hardware structure. So on RAM, and RAM has a computer node is over 800. The load all has 32 CPUs, and the available memory is about 125 gig. So that means the maximum physical core CPUs you can use for MATLAB PCT or for any type of shared memory code like OpenMP code. The maximum is 32. You cannot ask for more than that. Or if you ask more than that, your code still run, you will not get any benefit out of it. In Cedar's case, there are 2 types of hardware. So one is with 32 cores, and the other one is add up to Cedar not a long time ago. We have new hardware is up to 48 CPUs. So that means you have a chance on Cedar to use 32 CPUs to run one job, or could be use 48 CPUs to run one job. And then the question will be how many CPUs to use for your job. We played with these simple examples and try to have a clue how does the MATLAB perform on our systems. We hope sometimes the cutoff how to make sense. So this is basically for that Pi code. We try to run use different workers or CPUs and try to understand the timing and then the speed up. I think it runs quite good on RAM, and because this code I already talked is a simple code. however, is ideal code. The whole code is one loop. It's nothing before the loop and nothing before after loop. I mean, nothing is basically the others. Take a lot of time to do it. In your real code, you are not just one loop of your loops. You may have lots of operations out of the loops. So in that case, the parallel timing will be worse than this. So I would say this example speed up will be ideal situation in most cases for threaded. It's not just for MATLAB, it's for any type of OpenMP code as well. So you can see, well, it's overall it's good. So the sequential code may run over 30 minutes. And then as long as you increase the number of CPUs, the timing is actually down. So you get speed up. So I put two types. It's basically one type is the MATLAB use tick top for the MATLAB timing is. And then if you type SSAT, you can find the job history. You can find the elapsed times. That basically the system counted your time for a job. It may take a minute or two for the systems to open and close. Basically in line, a big difference. And you can see the ratio. So if you increase from 1 to 4 workers, basically is double. Your speed is double. And if you go all the way, you can see it's 1 to 16, it's pretty much 8 times. And all the way go to 32, it's about 13. Well, this ratio are calculated on the system's elapsed time. And on the TikTok, you will get a little bit better. So that's basically is for this example. So you can say the speed up is pretty much 50%. And so that's something will be good for you to keep in mind. If you want to say SSAT, you can find. If you want to say really how much compute resources your job actually consumed, you can type SSAT once the job is done. You can see, there will be a bunch of jobs there. You can say particular job. You can say how many CPUs you use and the elapsed time. So how long it actually job run, and you can say where it is located. And say CPU times is basically the time plus whatever the number of CPUs. And you can see how much memory is actually used. And then this will give you an idea where you're in a job, how much memory is a key, and how long your job to run. Because when you submit a job, if you ask for so long runtime, so much memory, your job will wait in the queue for longer. So you don't want to over ask request for the compute resources for the cluster. So this is basically the one we want to pass for effective usage. And I'm not quite confident to repeat these slides because the results is actually on Gram. We try to get the similar results on Cedar. Somehow, I didn't get it. And on Cedar's case, open PCT the pool takes about 30 to 40 minutes. That's for job run in a batch queue. If you run interactively, it seems to be okay. We still don't understand why. And if you run non-jobs, so your job need to run for days, for hours, it's okay. You run something like this, your job run for about 1 hour, and open a PCT about 30 minutes. Well, it will not be good. Okay, we just skip that. So what we want you to know, is your code. You understand your code, and well, it may be, to make your code better, you can use MATLAB code analyzer to check whether you can improve your code. And I got comments from very nice MATLAB supporter staff, Raymond, and he recommended this. I advise to use MATLAB code analyzer. I think that's a good idea. In our side, we do hope you understand how does your code scale. So in our side, we also try to run scaling benchmark like I did. So if you say from sequential code, you use 32 CPUs, and your code just speed up by 2 times. Well, maybe that's the option. You actually run up to 32 CPUs. Maybe 4 CPUs, you can reach to 1.5 or 1.8. So from our side, we hope the CPUs, the memories to use, and will be more to make it more effective. Because that's not only benefit you, it's actually benefit for all others who is waiting and who share the systems. Okay. And then the other one, I think, is for many the site license users on RAM. And again, this is my observation. Here is my observations. Because the site licenses, they are not unlimited. They are limited. So maybe some campus that only have, say, 10 or 20 or 30 PCT license for PCT. UW case, they used to have only 20 licenses for PCT toolbox. I think now it increased to 30. So if you have more users from that side that used most of them or many of them, if you want to submit jobs, a bunch of jobs, use PCT, you have a better chance will not work and will not give that many. MATLAB will not open that work as you did. So the safe one is where it's always maybe I will say the 12 will be safe. I tried many times, try to run 20, allocate 20 CPUs. And if you want to open PUB for 20 on RAM, use UW license, it will never work. If you run interactive mode and is say anything under 20, I can open that many workers interactively. However, if I submit a job to the queue, it will never actually be read them. I think it's something limited by the local site license. I don't know any other cases. So I don't know any other site licenses. So if you observe anything strange or anything not work the way you expected for, you can contact us, and we'll also hope to understand a little bit better. Okay. And then the other one is in PCT. I think major thing is SPMD, and the same examples you calculate the pi. And this one is actually you can and the all code is available on MathWorks website. And instead of you do it, is follow basically your works in your lab. And for example, you have 2 here, and SPMD has a bunch of keywords for you to use, such as the maximum number of labs. That's basically the number of works per pool open. And then each will come with an index. And say you have open 2, will be 1, maybe 0, 1, the other is 1. If you have 4, so 0, 1, 2, 3. So if you have any knowledge about OpenMP or sometimes MPI, you know those index, those IDs. And the MATLAB has a function actually to do it. It's called quadrature method. And the MATLAB has basically do all the plus to add all the integers or all the integrals all together. So this code is actually simple as well. So if you have this code, sequential code basically use a sequential code. So if you basically you define the intervals, and then you do integration each part, and then finally you add them together. This will run, and if you submit this type of job, so this will be the script. So you use one CPUs because your code is a sequential code there. And in this case, again, you run single COM thread. You can say in this case because it's basically the one lab, and you do it. It's like this, right? So if you want a SPMD, and it's basically open a parallel region. And here example, basically I have this a big region for everything. So I have SPMD here, and the end will be there. So the OR will do it. The other way you can say do this part with the SPMD open, and you will end here, you close. And then you open again and close, open again and close. So that's something to deal with. You want a bigger parallel region or want a smaller parallel region. That's the concept in open. In this case, if you want to run 4, in this case, and then you can find, or I print out everything, you can find you have 4 labs here. Each lab has add cut intervals. And then you can, each lab will do its own part, calculate partial of that pi. At the end, if I add them together, it will get lessons, right? So this is basically not only work for loop, it's basically SPMD for work tasks. If I have 4 workers, and each worker work on an independent task, that in overall will be parallelize your job and shorten the runtime. Okay. So I think that's the part for PCT. And the final thing I want to mention is that compile runtime. So compile runtime basically, MATLAB provides this runtime library, and we put it a different name on our systems to separate from the regular MATLAB. So the name we use is MCR. So if you type module spider, you will find tons of them. We have many of them. Well, maybe you don't use many of them. You just use one. For example, if you use MATLAB 2018A, you will load this module MCR20. In the case when you basically you use a MATLAB compiler, whatever MATLAB version you use, you have to match that version to run it, to use the MCR. So you always use the same versions. So on RAM and Cedar, and we have a procedure to do this. And when you compare your code, so the first thing you need to, again, you reserve interactive sessions. And then on the interactive node, you do module load, for example, 2018A. And if you have a code, in my case, I have this code, it's 4 pi. And then you run MCC, and you run this command. -m-r, no display, sequential code, and you use single COM thread. And then MATLAB will compile it, will generate basically 4 files or 5 files. So it will generate the binary, and then will be a log file, and then is there's 2 text files, and then we'll create a script, a batch script for you. Normal case, this will run. However, on systems, it may not work because MATLAB assume the libraries is in certain paths to find. It's actually the installation on the clusters is slightly different. So all the MCRs which have a script for you to set up the path. So then, and you can module load letter 2018A, you simply run this command once, set up R paths for that binary. And then you only need this binary to run on Cedar or RAM. If you compare the code, for example, some users don't have license to run MATLAB on RAM, and then you can, because you can run it on Cedar. And in case you want to use MCR, you can compile it on Cedar, because Cedar has the exact same environment as you can bring that binary to RAM, you can run it. And then the interactive run command will be run MCR binary.sh. That's also these two scripts comes with the package made by ComputerNet. And again, you can build, you can create a run script. In this case, because it's sequential code, and CPUs per task is 1, and this is the command for you to run compare to code. And you run this, your code will say, and the environment set up by on the system. So our MCR, I think there's two cases you will like to use. One is, say, you don't have licenses, right? And then you will use it. The other thing is basically if it's the same code, you take different input or data as input. You need to run the same code for many times, and then compare, and MCR will make sense for you. Okay. I can do a little bit demo here. I can try to show this part and how does it work, and hopefully the demo will not take for long. So the last slide I put it here is basically for the materials or examples. So I have all the code on RAM and also on Cedar under my home, and it's on the MATLAB directory. Graph you have access to. Or so you can go to take a look and follow some examples. You can try your own. And then this slide is basically a MATLAB.ppt, and also it's in that directory. And if you want to know more about the general, ComputerNet has a wiki page for MATLAB. You go to that web page, I think I opened one somewhere. Hope you can see this. So you type wiki. ComputerNet has a wiki page. You type wiki, and in the search part, you type MATLAB, whatever you want to search. So you can find the MATLAB page. So we talk about the license issues, and you build your own license, and talk about how to basically submit the jobs, and the simple examples there, and that's the syntax. Okay, and then if you go to, I hope you can see this page. Right now I'm on RAM. So I have all the files. So the PCT POP4 files are on the list directory. You can find tons of them. Some of the .log file may not make sense. But anyway, the SPMD files on the list directory. So you can find a few of them. And then sequential jobs is basically it's the one jobs there. So this is the is the file, and here is the Runtime file, and then here is the output. I think that's pretty much all for today.